What about the other trig functions? What about tangent? What about secant? What about cosecant? What about cotangent? Okay, now we have some other strategies to be able to deal with this. So let's look at if f of x is equal to, we usually go to the tangent next, so let's go to the tangent. How could we figure out the derivative of the tangent function? Let's rewrite the tangent as the sine over cosine. So let's rewrite the tangent of x as the sine of x divided by the cosine of x. So what you're finding by finding the derivative is actually d over dx of a sine of x over a cosine of x. And we need a quotient rule there. So remember what the quotient rule says. It says f prime times g minus f g prime, all divided by g squared. This was assuming that f was the function on the top and g was the function on the bottom. Okay, so we're going to use that quotient rule here that says the derivative of the top. The derivative of the top is the derivative of the sine of x. Now we know what that is. That's a cosine of x. So the derivative of the top and then times the bottom. Well, times the bottom is times another cosine of x, just copy and paste, minus the top, copy and paste the top, so minus the sine of x, times the derivative of the bottom. Well, the derivative of the bottom is the derivative of a cosine. We said that's not the sine, it's almost the sine. It is a negative sine of x. Okay, and then don't forget that with the quotient rule, you always need on the bottom, you need the bottom squared, so g squared. So in this case, that is cosine of x squared. Okay, now some nice things here are going to happen because on the top, what you have is cosine squared of x, and then minus a negative in there, so you end up getting plus sine squared of x. And that should just jump off the page as one that you're very familiar with, back from a trig course or just any kind of your trig experiences in your background. Remember, cosine squared plus sine squared, that's a Pythagorean identity, that's equal to 1. And so we get 1 over the cosine squared of x, which you may remember another way to write that. That is the secant squared of x, because 1 over the cosine is equal to the secant. Okay, so I told you that when we take the derivative of a trig function, we shouldn't be surprised that we get a different trig function. In this case, when we take the derivative of a tangent, we don't just get a secant, we get a secant squared of x. Okay, so we can actually do something really similar for all three of the other ones, because the cotangent graph, you can write not as the sine over the cosine, but rather the cosine of x over the sine of x. Okay, and I think it would be better to write it like that for right now, rather than kind of thinking about the cotangent as being 1 over the tangent. That can be a little tricky. I guess either way it works fine. With 1 over the tangent, you could still deal with that as a quotient rule there. That's fine. But either way, you're going to use a quotient rule no matter what. And then when you're talking about a secant of x, remember that the secant is 1 over the cosine. And when you're talking about a cosecant of x, that is 1 over the sine of x. So actually what you're going to end up having for this is if you're talking about the derivative of any of these, you're going to use a quotient rule. So for example, the derivative of a secant is equal to, you have the derivative of the top is the derivative of 1, that's just 0, times the bottom, minus the top, times the derivative of the bottom. Remember the derivative of a cosine is a negative sine of x, and then all divided by cosine squared of x. Okay, so you can simplify this a little bit, and you can do this with all three of these. I won't walk through every detail of every trig function here, but what you end up getting here is that the derivative of a secant of x, let's see, 0 times cosine is just 0. You end up getting a positive sine of x divided by a cosine squared of x. And another way to write that is to write it as 1 over a cosine of x times the sine of x over a cosine of x. And kind of the goal here is to write it with as few functions as we need, or few functions as possible. And so 1 over the cosine is a secant of x, and then sine over a cosine is a tangent of x. Okay. So secant of x times tangent of x is another way to write that with two trig functions and with multiplication instead of division. So you get something really similar when you talk about the derivative of a cosecant. I believe you get a negative cosecant of x times cotangent of x. And then for cotangent of x, it works very similar to how the tangent worked, but I think you end up getting a negative for that one as well. I think you end up getting a negative cosecant squared of x. So just something to think about. You can add all these trig functions to your database of derivatives and use these a lot to be able to remember them. So if we were to write all these out, we would have something like this. D over dx of the sine of x is equal to the cosine of x. D over dx of the cosine of x is equal to negative sine of x. D over dx of the tangent of x is equal to the secant squared. D over dx of the cotangent of x is equal to a negative cosecant squared. And then d over dx of a secant of x is equal to a secant of x times the tangent of x. And then d over dx, last but not least, d over dx of the cosecant of x is equal to a negative cosecant of x times the cotangent of x. Okay, so these are all 6. And now that you know the derivatives of all 6 trig functions, now you can start to incorporate those into using some of your other rules and combining with some of the other functions that we have as well. All right, so let's go ahead and take a look at some examples. If f of x is equal to x squared times sine of x, okay, we can go ahead and find that derivative. Again, I'm not always going to point this out for you. Did you see that there's a product rule in there? Okay, so we need to be able to recognize that multiplication. So we're going to use a product rule. The derivative of the first is 2x. Copy and paste the second is a sine of x, plus the first, copy and paste to an x squared, and then times the derivative of the second, so times the cosine of x. And sometimes you might be able to simplify these, and sometimes you can't. That's okay, not a problem. Trig functions are interesting also because their behavior repeats. That's why they're periodic, but also it's interesting to note then that the derivative behavior repeats as well. For example, let's say we have a function that's just the sine of x, and we know what its derivative looks like now. We know that f prime of x is equal to the cosine of x. And in a past class, we talked about not just finding a derivative, but we could also find the derivative of the derivative, or we called it the second derivative. And we could go ahead and we could find that and see what happens here. So f double prime of x is the derivative of a cosine, which we know is a negative sine of x. And so kind of interesting behavior that these derivatives are going to repeat, because if we look at f triple prime, the third derivative, we would have the derivative of a negative sine of x. We can just leave that negative out front. That's like a constant multiplier out front. And then take the derivative of the sine of x, which is the cosine of x. And so the third derivative of our original function f gives us a negative cosine of x. And what happens if we take a fourth derivative, which, a little bit of notation here as well. I could just keep putting an extra little prime symbol every time, but then it's hard. I got to kind of add, I got to count how many there are and pay attention to all that. So sometimes instead of, when you get to higher derivatives, instead of continuing to put little prime symbols every time, we sometimes do this, where it looks like an exponent, but it's in parentheses. And so if you see something like this, this doesn't mean f to the fourth power. This means the fourth derivative of f. Okay, and if we take the fourth derivative of this, we would leave the negative out front and take the derivative of the cosine of x. But the derivative of cosine of x is a negative sine of x. So we have the negative out front and the negative in the sine. This just becomes a sine of x, which actually is exactly the same function that we started with. And so trig functions like this, especially sine and cosine like this, they're not only does their behavior of their function repeat, but the behavior of their derivatives repeat. And so this is actually kind of interesting because if, let's say, we had a function that was the sine of x here, could we find the, I don't know, I'll just throw this out. How about the 47th derivative? Okay, 47th derivative. Now, this is kind of crazy, but you don't have to go and actually find all 47 derivatives because remember that this behavior is going to kind of repeat itself every fourth derivative. So if the fourth derivative of f is also the sine of x that you started with, then every multiple of 4, so the fourth derivative, the 8th derivative, the 12th derivative, the 16th derivative, so on and so forth, that also means the 44th derivative, which is a multiple of 4 in there, is also going to be, not f prime of 4, f prime of x, okay, is going to be the sine of x also. We basically start the process over again. And so if the 44th derivative of f is the sine of x, what's the 47th derivative? Well, this would be like 44, 45, 46, and that means that the 47th derivative is kind of this repeating behavior here. You would end up getting a negative cosine of x. Okay, let's look at one last example because we've talked about product rules, we talked about a quotient rule. We haven't seen a problem yet that kind of combines those two rules together. So, I'm kind of telling you up front that that's what's going to happen here in this problem. Let's say we have something like t times the sine of t all over 1 plus t. Okay, and notice here that yes, there is a quotient, there's a fraction, but there's also this t times sine of t. There's actually a product rule in there as well. Okay, so we're going to combine a lot of our rules together and things are going to continue to get more complicated. We got to keep track of our pieces. So y prime, if we're trying to find the derivative here, I want to set up the structure for you. Okay, so the structure for us, overall, the overall structure here is that we have a fraction, so we have a quotient rule. So remember what a quotient rule says is that f prime, and I'll just go ahead and put parentheses here as placeholders, and then we'll kind of fill stuff in. So f prime times g minus fg prime, and then all divided by g squared. Okay, we know what g is. G is 1 plus t squared, so just kind of copy and paste the bottom there. All right, so here's our structure, and then we can start to kind of fill in the pieces that we have. But f prime, this first part, says what's the derivative of the top? Well, the derivative of the top actually involves using a product rule, and so that piece is actually going to be a little bit more complicated. It's not just the derivative of one function. There's a product rule in there. So I'm going to fill in the other ones first, and then we'll do that one last. So f prime, and then g just says copy and paste g, and then minus f, which is just copy and paste the top, so t times the sine of t, and then times the derivative of the bottom. Well, the derivative of the bottom is actually pretty straightforward. That's just a 1. Okay, and so here's the rest of the pieces, and the only thing I haven't done yet is found the derivative of the top. Notice I'm kind of expanding my parentheses to give myself a little bit more space, because we know we're going to need a product rule in the top. There's going to be a little bit more complicated piece in that parentheses. So here the derivative of the top is a product rule. So in the product rule, we need the derivative of the first, which is 1, times the second, plus the first times the derivative of the second, which is a cosine of t. Okay, now you might be able to simplify this when it's all said and done, but I don't know. We don't need to try to do a whole lot with this. Usually, we can kind of leave this. If we can clean it up a little bit, that's fine. But a lot of the times when we have functions that are not related to each other, like polynomials and trig functions, there's not much you can do all the time to be able to simplify those. So it's fine for you for now just to kind of leave this problem right here to talk about its derivative. Okay, so that's going to be it for examples today. I hope you've enjoyed the video. Good luck practicing.